Hi guys, I Aziz welcome you to CoedMaster, and in this video I am going to talk about coupling in object-oriented programming. In this video I will explain what is coupling, what is the difference between loose coupling and tight coupling, what are the disadvantages of tight coupling, and how can we achieve loose coupling in object-oriented programming. So guys, if you are willing to know about coupling in object-oriented programming, then this video is for you. Make sure to watch this video till the end, and without wasting any time, let's get started. Alright guys, let's begin this video with the very first question, that what is mean by coupling? Well, coupling is a device for connecting parts of machinery. So when we connect two parts of machinery with a device, then we call it as two parts of machinery is coupled with each other. This is the meaning of coupling outside of context of object-oriented programming, right? Now that is okay, but what is the actual meaning of coupling in context to object-oriented programming? So let's see it. So with context to object-oriented programming, coupling is the degree to which one class knows about another class. If one class uses another class, then it is called coupling. So I know this definition is a bit difficult to you. Don't worry, I will explain coupling with a very simple example. So let's understand the coupling with this example. So let's say here we have a car class on the left side and we have music player class on the right side. Now music player class has three methods. One method is to play music player, one method is to pause music player, and one method is to stop music player. Okay. Now in car class is creating an instance of music player to play the music, to pause the music, and to stop the music. Now guys, if you look at these two classes are strongly tightly coupled with each other. And why is it so? Let me show you. So guys, if this car wants to communicate with music player, then it is necessary that the car should be having an instance of music player. That is why it is creating an instance of music player, right? Now in order to communicate with music player, the car class must call the method of music player, and that is why it is calling the method of music player play, which means we can say that the car and music player is collaborated with each other to make it work, right? And because of this collaboration, we can say that both the class are tightly coupled with each other. As simple as that, right? And you can also see that the car is directly dependent on music player class. Why? Because the car class is creating an instance of music player inside of its constructor. So overall we can say that car is directly dependent on music player. And if there is any strong dependency between two modules, then we can say that these two modules are tightly coupled with each other. Okay, I think this is clear to you. Now the question over here is, what is the problem or disadvantage with this type of design? So let me tell you all the problems or disadvantage of this type of design. So the first problem is, if we change or introduce any change in the music player class, it will directly impact the car class. Why is it so? Because car directly depends upon the music player, right? If I change any method of music player, or if I introduce new methods in music player class, or if I do any minor change on music player, there are possibilities that it will make a ripple effect in the car class. This is the first disadvantage. Now the second disadvantage is, what if you want to change the music player? We cannot change it, right? If we want to change the music player, then we have to go to car class and create a new instance of new music player. But it never happened like this in the real world, right? In real world, if we want to change the music player, then we do not need to open the car and change the music player, right? We just have to pull the old music player and put the new music player, that's it. But here it is not happening. Here we have to go into the car class and change the car class in order to use the new music player, right? So that is why it is tightly coupled. And this is the second disadvantage of using this design, okay? Now the third disadvantage is, we cannot reuse the module. So for example, I want to reuse the car module somewhere else. I cannot use it. Why? Because car class by default comes with music player. But I don't want music player, right? I only need car class. So I cannot reuse it. As simple as that. And the fourth disadvantage of using this design is, I cannot test individual modules. So for example, let's say I want to test car module. Then I cannot test car module. Why is it so? Because if I go and test car module, then it by default comes with music player. But I do not want to test car with this music player. For example, I want to test this car with the different music player. Then each time I want to test car with different music player, I have to go to the car class and change the music player. So it becomes very tidy process and becomes more complicated to test individual modules. So basically these are all the disadvantage of using tightly coupled design. Now the question over here is how to solve this problem. Well, the solution is simple. We should always strive for loosely coupled design, right? Now the question is how to achieve loosely coupled design. So guys, there are two ways we can achieve loosely coupled design. One is through the dependency injection and one is through the interface. So in this video, we will see how we can achieve loosely coupled design using interfaces. So let me take you to my IDE where I will show you how we can convert this tightly coupled design into loosely coupled design. Okay, so guys, we are finally on the IDE. So let's see here. So we have one car class and we have two music players, right? So first of all, we have to use interface to convert the tightly coupled design into loosely coupled design, right? So because of that, I have created one interface music player, and this music player defines three methods. One is for play, one is for pause, and one is for stop. Now here, this music player interface acts as a contract between car and the music player. Okay, so we have two types of music player. One is Bix music player and one is Vid music player. Now both the music player implements this music player interface, which means if this class wants to become a music player, then it must follow this contract. And what this contract says, that it must implement these three methods to become a music player. So this is what happening here, that this music player is implementing this contract, and this music player is giving an implementation of play method, pause method, and stop method, right? Similarly, we have another music player, and this music player is also following the same contract, and it is also giving an implementation of play method, pause method, and stop method. Now these are the two types of music player, and this is a contract of music player. Now let's go to car class. Now inside of car class, we have a variable music player, and now this variable is bind with the contract rather than the concrete class. So you can see over here is that we are not using any instance of music player class. We are simply binding the car class with the contract of music player, not the concrete class of music player, right? So here you can see that this music player is an interface. Here also it is interface. So we have one method over here which is used to set the music player in the car. And this is what we do in real life also. We simply pull out the music player and put the new music player. So basically we are setting new music player in the car. And then we have play method. Again, this play method is using a contract and then calling play method on this contract. Okay, and so on and so forth. So using this method, we are going to set music player, and then we are good to go. We can play music player, pause music player, and stop music player. Similarly, if you want to change any music player, then we can use this set music player method again to pass the new music player, and then we can similarly play, pause, and stop. Now let's go to main Java class. Now here you can see the loosely coupled design in action. Okay, so first of all, I am creating an instance of car. Then I am creating an instance of Bix music player, and using set music player method of car class, I am setting this music player into this car, right? And then I am playing, pausing, and stopping. So let's run the program. So if you look at this output, you can see that our Bix player is playing, pausing, and stopping. Okay. Now comes the real challenge. Let's say tomorrow I want to change the music player. Then I do not need to go to the car class and create a new instance of that music player and update the car class. I do not have to do that. What I have to do that? I have to simply call car.set music player. Then let's create a new instance of new music player. Let's say now I want to use Vid music player. So I am simply creating a new instance of Vid music player and setting it in this car using set music player. Now again we can use the same method over here. Let's run the program, and now you can see that first we were using Bix music player, and then we updated the music player of our car, and now we are using Vid music player. So Vid music player is also playing, stopping, pausing. So this is how we achieve loosely coupled design using interfaces. Now this type of design has solved all of our problems. And what are the problems? The problem was, now if I want to change anything in the music player, it's not going to create a ripple effect on the car class, right? Because car class is not directly or tightly coupled with music player. Instead, it is coupled with contract. So which means whichever class that follows this contract can be used inside of this class, right? As simple as that. And whenever we want to change any music player, we do not have to come to the car class to update the car class. We simply can use the set method or set music player method of this car class to update the music player. And the next advantage is now we can also reuse this module. If I want to use the car, I can use. If I want to reuse the music player, I can use, and so on and so forth. And lastly, we can test individual modules very easily. Let's say I want to test car module, then this time car class doesn't come with the music player, so we can test this module easily. And similarly, we can individually test music player module and the with music player module, because all of these classes are now not dependent on each other. Instead, they are loosely coupled with each other using contract. So guys, by now I hope that you understood the concept of coupling. What is difference between loose coupling and tight coupling? How can we achieve loose coupling, and what are the advantage of having a loosely coupled design? So this is all from my side for this video, guys. If you learned something valuable from this video, then hit the like button in order to make YouTube algorithm happy. Please subscribe to this channel and don't forget to click the bell icon so my friend you never miss any upcoming videos. Thanks for watching. See you in the next one.